Alright, this is derivatives of inverse trig functions. I'm going to kind of just list these for you guys so you can kind of remember how to, just to jog your memory a little bit. First one is the derivative of sine inverse of u, and that turns out to be 1 over the square root of 1 minus u squared times the derivative of whatever u is with respect to x. Okay? Now the second one, and why I didn't have it listed yet, is the derivative of cosine inverse. And just like how all the cofunctions for regular trig, the derivatives were opposite, these are exactly opposite. You don't have to, they're not slightly different. They're all negative, but they're all completely opposite. They're just the negative version of the original on the left side here. So, if we take the derivative of cosine inverse of u, it's just negative 1 over the square root of 1 minus u squared times the derivative of u with respect to x. Okay? And the others will follow suit. Clearly this is a different derivative though, so we have to tell you what that one is. This one is 1 over, for tangent inverse, 1 over 1 plus u squared times again the derivative of du dx, which makes cotangent, which will be my fourth one, the derivative of cotangent inverse of u, that's just going to equal the negative, or opposite, of tan inverse, derivative of tan inverse. So, that is that one. Okay? And the trickier one, this is kind of like sine, but a little different. It's 1 over, and then you have the absolute value of u, and then it's the square root of u squared minus 1. So it's a flipped around from the one that's sine inverse. And then again, number 6, cosecant inverse of u is equal to the opposite. So negative 1 over the absolute value of u times the square root of u squared minus 1. And that is then times, the whole thing is times the derivative du dx. Okay, so those are the 6 derivatives of inverse trig functions. So, let's just do some examples. Write those down, pause it, I'm going to go on. So, example 1. I want to know what the derivative is of sine inverse of x squared. Okay, well, since x squared is our u in this equation, we just, wherever we saw a u for the formula, we plug in an x squared. So this is the one where it's 1 over the square root of 1 minus u squared. So we're going to do 1 over square root of 1 minus x squared squared times, don't forget the times, the derivative of u, which is 2x. So we get, our final answer is 2x on top over the square root of 1 minus x to the 4th. And that's the final answer. Okay, let's try a couple more. We're just going to do the more basic ones for the video so you guys get a handle on it again. So I want to know what the derivative is of secant inverse of 5x to the 4th. Okay, so we just plug our u in as 5x to the 4th, so we get 1 over the absolute value of 5x to the 4th times the square root of 5x to the 4th quantity squared minus 1 times the derivative of 5x to the 4th. So the derivative of 5x to the 4th is 20x cubed. So let's see what happens here. Now, note this absolute value of 5x to the 4th. There is nothing that can make that negative inside of there. So this will always be positive regardless, because the 4th power will always make something positive. So the absolute value sign is actually redundant here. So we can get rid of it. So I'm going to rewrite this as 20x cubed over just 5x to the 4th times the square root of 25x to the 8th minus 1. And finally we can simplify the outsides if you want. 20 divided by 5, 4 over x square root 25x to the 8th minus 1. Okay. All right, let's do 2 or 3 more. I want to know what if I give you y is equal to x square root of 1 minus x squared plus cosine inverse of x. I want to take the derivative of this. So find the derivative. Okay, you don't have to do implicit because y is on the left. So this is going to turn into, hopefully you guys notice that this has to be a product rule. I'm going to rewrite this though before I do the derivative. It's x times the quantity 1 minus x squared to the 1/2 plus cosine inverse of x. Now be careful. This is cosine inverse. It's not cosine to the negative first power. Okay? So you're not going to do a power rule with cosine. You're going to use cosine inverse. Alright, so let's take the derivative. So y prime is equal to, I have to do product rule. So I'm going to keep x by itself, x, times the derivative of this piece. We're going to have to use power and then take the derivative of the inside, so it's a chain. We have 1/2. This stays the same. Remember when you use chain rule, the inside stays the same. This goes to negative 1/2. And then this is going to be times the derivative of the inside, which is negative 2x. Okay. Alright, so that's that piece. Plus, we now keep this the same, and then times the derivative of x, which is 1, plus the derivative of that, which is actually a negative 1 over the square root of 1 minus x squared. Since it's x, the derivative of x is just 1, so we don't have to multiply by anything but 1 there. Okay, so we have this mess here. Let's try to simplify this a little bit. Alright, we have this piece, which is itself. This cancels. The negative 2 and the 1/2 go to a negative 1, x squared on top. So we get a negative x squared over, because this was a negative exponent, the square root of 1 minus x squared. Okay? Plus, I have the square root of 1 minus x squared on top over 1 minus 1 over the square root of 1 minus x squared. So we can actually combine these now by getting a common denominator. And the way to do that is multiply the top and bottom here by the root of 1 minus x squared. So we get, so now we have a common denominator. So the tops we have to just add and subtract. So I get a negative x squared plus a 1 minus x squared minus 1 all over the square root of 1 minus x squared. And if you notice, the negative x squareds become negative 2x squared, the 1's cancel, so the final derivative with simplifying is y prime is equal to negative 2x squared over the square root of 1 minus x squared. And that's just some algebra to get it into one fraction. Okay. Next, we're going to do another one. We'll do example 4, I believe we're on. Y is equal to cosecant inverse of x over 2. Okay. So again, it's the opposite if we take the derivative. So take derivative. We get y prime is equal to negative 1 over the absolute value of x over 2 times the square root of x over 2 quantity squared minus 1 times the derivative of x over 2. You have to think of this as 1/2 x, so the derivative of 1/2 x is 1 over 2. So we can rewrite this as just negative 1 over 2 absolute value of x over 2 square root of x squared over 4 minus 1. And we can leave it like that. Yeah, we'll just leave it like that for this one. Sometimes the book takes out the fraction here out of the square root and goes from there, but we can just leave that one like that. And finally, if y is equal to the cotangent inverse of the square root of t, I'm going to rewrite this first because, again, square roots, you like to have I like to have fractional exponents. Okay, so cotangent's the opposite of tangent inverse, so we're going to have -1 over, and then this is 1 plus u squared, or I guess u squared plus 1, it doesn't really matter. 1 plus t to the 1/2 squared, okay, times the derivative of t to the 1/2, which is 1/2 t to the -1/2. Okay, so this turns into -1 over 1 plus t times this becomes 1 over, there's a 2 and the root t down here, so we can rewrite that as -1 over 2 root t 1 plus t. And that's the final answer. Okay, so that's just using our new definitions for derivatives of inverse trig functions to take derivatives of inverse trig functions.